All right, so the lab that we're doing today is the HR diagram lab. Now, when you look at the stars at night, what you should notice about them is a couple things. One is that some stars are brighter than other stars. And the other thing is, if you look at them closely, they're actually different colors. Some stars are bluish in color, some stars are reddish in color, some stars are yellowish in color, some are whitish in color, some are orange in color, and so forth. Now, based on those two characteristics, how bright they are and their color, and what determines the color is their temperature. How hot it is determines what their color is. These two guys, one guy by the name of Hertzsprung, another guy by the name of Russell, came up with a method of classifying the stars based on those characteristics. Now, Russell was an American, Hertzsprung was in Europe. They both kind of discovered the same thing at the same time, so they both got credit. So the diagram they came up with is called a Hertzsprung-Russell diagram, and it doesn't really roll off the tongue so easily, so most people just call it an HR diagram now. But it's a diagram that classifies stars based on those two characteristics. So, that's what this chart here is. Right? So over here, this is how bright the star is, and what these numbers do is they compare the brightness of the sun. So they give the sun a brightness of 1, and that's 10 times brighter than the sun, 100 times brighter than the sun, 1,000 times brighter than the sun, 1/10 as bright as the sun, 100th as bright as the sun, and so forth. Then down here it has the temperatures. So here it has 30,000 degrees, 20,000 degrees, 10,000, all the way down to 2,000 degrees. So it starts off hotter over here and goes cooler over here. And then underneath that, it gives you the colors. So red, orange, yellow, white, and blue. So you can see the reds are going to be the cooler stars, around 2,500, 3,000 degrees or so. And then the blues are going to be the hottest stars. All right. Now, when you take the brightness and the temperature or color of the stars, and then you plot them all on this graph, what we find is most of the stars belong in what we call the main sequence. The main sequence is the early age of a star. So this is where this is where most stars plot, is in the main sequence. Right? Now, as time goes by, a star doesn't stay in one spot though. As time goes by, as billions of years go by, stars will move from the early stage main sequence. As they get older, they start to cool down and they become a giant star. And then they're there for a while, and then as they get even older yet, what happens is they heat up, but they become dimmer and become a white dwarf, which is like a really small star, but it's hot, but it's really small and doesn't give off very much light. All right, now what you're going to do in this lab is you are given a list of stars. And these stars here are the 15 nearest stars to the Earth. All right, so Sun's the nearest one, Proxima, Alpha Centauri, and so forth. 15 stars closest to the Earth. It gives you the temperature and it gives you how bright they are. Now notice a lot of these numbers are really, really small. 0.0004, that means they're very, very dim stars, but they're still a star nonetheless. All right, so what you're going to do is you're going to use one colored pencil, and what you're going to do with this is you're going to plot points on your HR diagram to see where they fall. So for example, the sun, 5,600, temperature to brightness of 1. So I'd go 5,600 be right about there, brightness of 1. So I put like a data point right there. Right? So you're going to do this whole list of stars in one colored pencil. Now, if you don't have a colored pencil, you can put like little little stars on the chart to represent them. Now, then you're going to pick a different colored pencil, and you're going to plot the second list of stars. Now, the second list of stars is, these are the 15 stars that are brightest in the sky. These are the 15 stars that are brightest in the sky. So you can see their temperatures and how bright they are. So, for example, Antares has a brightness of 4,400. That's 4,400 times brighter than the sun. Rigel is 40,000. That's 40,000 times brighter than the sun. So these are really bright stars. So you're going to pick a different colored pencil, and then you're going to plot those stars on this chart as well. And what we want to find out is which group of stars are the more common ordinary stars. Because if they're in the main sequence, they're more of a normal star. If they're outside the main sequence, that means it's a star that's kind of on its way out, it's dying. So you're going to see which group plots more in the main sequence. The stars that are nearest the sun, or nearest the earth, or the stars that are brightest in the sky. What you also want to do is you also want to lightly shade in with some pencil the main sequence right there. If you don't have colored pencils, then for the second list of stars, instead of using a different color, you can just put little asterisks to represent the stars on the graph if you don't have another colored pencil. It's easier if you use two colored pencils, but if you don't have colored pencils, you can use, you can draw little stars for the first list, and you can put little asterisks for the second list. And then you just have to answer the questions based on what you've plotted. And that is it.